let's do section 4.3 where we learn about some more discrete probability distributions. In 4.2, we learned about the binomial distribution. We're going to learn two more discrete probability distributions. So the two that we're going to talk about are the geometric and the Poisson distributions. So a geometric distribution is a discrete probability distribution that satisfies the following conditions. A trial is repeated until a success occurs. The repeated trials are independent of each other. So an example that we're going to do is about LeBron James making free throw shots. So for what I'm talking about, the trial is repeated until a success occurs. He's going to throw the basketball until he makes a success. He makes a basket. And the trials are repeated and independent of each other because if he throws the first one, it has nothing to do with whether he makes on the second one or not. Each basket is independent of each other, the making the success of the basket. The probability P is constant for each child. The probability of him making a basket is the same for each of his throws. And X represents the number of the trial in which the first success occurs. So if you want to find the probability he makes a basket on the 10th shot that he makes, X is 10. Or the probability he makes it on the second shot, then X is 2. Because he's going to keep repeating this process until a success occurs. So the probability that the first success will occur on the xth trial is P of X is P, which is the probability of success, times Q, the probability of a failure, to the X minus 1. And Q is 1 minus P, as we've seen in the past. So the example, basketball player LeBron James makes a free throw shot about 74% of the time. So that's probability of his success. Find the probability the first free throw shot LeBron James makes occurs on the third or fourth shot. So if it occurs on the third shot, that means he missed a basket, then made the basket. So he was successful on the third. The fourth attempt would be he failed 3 times, so he didn't make the basket his first 3 shots, and then was successful on the fourth. So he's repeating it until he was successful. So for this one, since it is geometric, and we want to find the probability of it making it on the third or the fourth, we're going to add, because or means add. With the geometric, your P is the probability of success. In this case, he makes the basket 74% of the time, so P is 0.74. Q, you subtract 0.74 from 1 to get 0.26, and my X is going to be 3, representing on the third trial, and then we're also going to do it when X equals 4 for P of 4. So we have our geometric formula. P of X is P times Q to the X minus 1. So P of 3, the probability the success occurs on the third trial, is the probability of success, 0.74, times probability of a failure, 0.26, to the X minus 1, where X is the trial number, so the third trial. And you plug this into your calculator. Please follow along to make sure you get the same answer. And then also for P of 4 we had to find. So here X is 4, so it's P, the probability of success is 0.74, probability of failure 0.26 to the X, in this case X is 4 minus 1. And you get that. Since we want to know the probability is made on the third or fourth attempt, we're going to add our two probabilities together. And when we add our two probabilities together, you get 0.063. And that is an example of a geometric distribution where you keep trying until a success occurs. And you're finding the probability that the success occurs on the X trial. The next distribution we're going to talk about is the Poisson distribution. The Poisson distribution is a discrete probability distribution that satisfies the following conditions. The experiment consists of counting the number of times X, an event, occurs in a given interval. So the number of times something happens in a given time frame, some sort of interval. The interval can be an interval of time. Sometimes it could be area or volume. We're going to do an example today about time. The probability of event occurring is the same for each interval. And the number of occurrences in one interval is independent of the number of occurrences in other intervals. The conditions continued would be that the probability of exactly X occurrences in the interval is P of X is the mean, mu, to the X power, and that would be your given. E, that's your natural number. It's a button on your calculator. It's about 2.7 to the minus mu, that's the mean, over X, the probability of X occurrences interval, factorial. Okay, so mu is the mean, E is about 2.7, and it's a button on your calculator. So let's do an example. The mean number of accidents per month at a certain intersection is 3. So here we're told mean is 3, so our mu is 3. What's the probability that in any given month 4 accidents will occur at this intersection? So in this example, the interval that we're talking about is a month. So in 1 month, on average, 3 accidents occur. But I want to know what's the probability that 4 accidents is going to occur in this intersection. So in this sample, my x is 4, and I want to know what's the probability that it occurs 4 times when the average is 3. So it's a Poisson distribution with x equals 4 and my mean equals 3. So I'm going to plug it into my Poisson formula. I'm going to plug in my x is 4 and I'm going to plug in my mean is 3. So when I plug in those numbers, remember e is about 2.7, we can just go ahead and press that button on your calculator instead of typing all of these numbers in. So I have my mean is 3, my x is 4, e is about 2.7. Feel free to use the e button. To the negative mu, which is our mean, which is 3, divided by x factorial. In this case, x is 4 factorial. So please follow along and make sure you can type this into your calculator correctly. Divide by 4 factorial to get about 0.168. So since we are calculating what is the probability that in any given month 4 accidents will occur in this intersection, the probability that 4 accidents will occur in a month is about 0.168. So, about 16% chance that an accident will occur in this intersection in a given month. So kind of high when you're talking about an accident. Okay, so that is an example of a Poisson. We also did the geometric distribution.